Hello and welcome to my YouTube channel. Today we are going to learn about arithmetic operations in PLC programming, and we shall start with integer functions. I have opened my Arithmetic manager and I have two networks on the screen. We have network 1 and network 2, and I'll show you how we can actually perform arithmetic operations using a PLC. First, expand on the integer function, and we have add, subtraction, multiplication, and so on. So in my first network, I'll include an additional block, and in my second network I'll include a subtraction block, and we shall see how the two will work. Both blocks, the addition block and the subtraction block, we have input 1, input 2, and an output. At the inputs, this is where you put the values that you want to either add, subtract, multiply, divide. Then at the output, this is where you get the answer or the result of that arithmetic operation. For instance, at this additional block, if I put a value at input 1, say 10, and then I put 5 at input 2, here at the output I'll have to assign a memory where the result will be stored. I'll give it MW0. If we enable I0.0 signal, you can see that this block has done the addition of 10 and 5, and the resulting answer is 15. Now, instead of giving values at input 1 and input 2, I can assign a memory address. Let's call it MW2, and this other one, let's call it MW4. Same as this one. This one I'll give MW2, and this one I'll give it MW4, and for the output MW0. At the first input, which is held in memory word 2, we have 0, and at the second input we have 16,456. So when you perform the addition of the 2 in the first block, this is the answer you get, and in the second block, which is subtracting, you get negative. You get a negative value because it's 0 minus this value here. I can modify the values. Let's say for the first input we put 55, and for the second input we put 5. You can see the first block has done the addition, and 55 plus 5 we get 60, and also for the second network it has performed the subtraction. 55 minus 5 we get 50. We then have multiplication and division. I'll add a multiplication block in my first network and a division block in my second network. For the input 1, I'll give it M0, same as this one, MW0. And for the second input, I'll give it memory word 2, same as this one. Then for the output, I'll give it MW4, same as this one. The purpose of this normally open contact here is to enable this function. As you can see, even if I modify these values in here, you cannot get an output until I give a signal at I0.0. For instance, if I modify this first input and I give it, let's say, 100, and the second input I modify it and give it to, you can see that nothing happens. But when I give a signal at I0.0, then we get an output, which 100 multiplied by 2, you get 200, and 100 divided by 2, you get 50. We then have this other function. It's an addition, and then we have this subtraction. The difference between these and these ones is, for this one, they deal with double integers. And so the memory here, we shall assign MD0. The next one will be MD4. And for the output, it will be MD8. Same as this one. Let's modify our first input and give it, let's say, 1000. And our second input, we give it 2. This first block has performed addition, and you get the, and here you get the result, and this one here has done the subtraction. We then have these ones for the multiplication and for the division. Again, this one will only operate with double integers, so the memory will be double word. So that one will be MD0. This one will be MD4. This one will be MD8. So our memories already had values. So our MD0 had 1000 and MD4 had a 2. You can already see the result. That 1000 multiplied by 2, you get 2000. And for the division, we have 1000 divided by 2, and you get 500. Again, we can modify these values. For the 1000, we can put 500. Then our second input, we put a 5. And as you can see, the first block, when you multiply 500 and 5, you get 2500. And if you divide 500 by 5, you get 100. We then have this last function. It has 2 inputs and 1 output. Again, the memory address will be a double word. For this particular function, it is used to do the division, but you'll only get the remainder as the output. For instance, here, if you divide 500 by 5, you get 100, and so there is no remainder there, and that's why your output here is 0. If we modify these values, let's say here I put 100, and for the second input we put 30. You see, here at the output you get 10, because 10 is the remainder after you divide 100 with 30. We can modify again. Maybe I put a 15 there, and for the second input we give maybe 6, and here at the output you get a 3. So that's it, guys. I hope you have really enjoyed this video, and kindly don't forget to subscribe to our channel.